Hello, everyone, and welcome. Today, we're going on a journey back in time to explore the incredible engineering feats behind ancient bridges. Forget modern steel and concrete for a moment. We're talking about structures built with stone, wood, and an ingenuity that still amazes us today. These bridges weren't just pathways across rivers. They were testaments to human problem-solving, resourcefulness, and a deep understanding of the natural world. Before we dive in, if you find this journey through ancient engineering fascinating, hit that like button and subscribe for more explorations of the past and the clever minds that built our world. Now let's travel back in time and cross some impressive ancient spans. What ancient structure are you most curious about? Let me know in the comments. Our exploration begins with a fundamental question: why build bridges in the first place? The obvious answer is to overcome geographical barriers, rivers, canyons, valleys. But it's more than that. Bridges facilitated trade, connecting communities and enabling the exchange of goods and ideas. They allowed armies to move swiftly, playing a crucial role in warfare and expansion. And in many cases, they were symbols of power and prestige, demonstrating a civilization's ability to conquer nature itself. The sheer determination to overcome these obstacles required planning and knowledge, which is the genesis for engineering. The materials used in ancient bridge construction varied dramatically depending on what was available locally. In regions rich in stone, like the Roman Empire, arches and vaults dominated, creating bridges that could withstand immense weight and last for centuries. Wood was another common choice, particularly in areas with abundant forests. Timber bridges were often lighter and easier to construct than stone bridges, but they required more frequent maintenance and were susceptible to fire and decay. One of the earliest forms of bridge was the simple beam bridge. Imagine a fallen log spanning a stream. That's the basic principle. Ancient engineers would lay beams of wood or stone across two supports, creating a flat surface to walk or ride upon. While simple in design, beam bridges were limited in the distance they could span. The longer the beam, the greater the risk of it sagging or breaking under its own weight. Consequently, these were best used for relatively short distances. Stepping stones represent an even more basic bridge design. Imagine carefully placed rocks emerging from the water, creating a path across a river or stream. These weren't always natural formations. Often, they were deliberately placed by people to facilitate crossing. Stepping stones were obviously only suitable for shallow water and light traffic, but they demonstrate a fundamental understanding of how to create a usable pathway where one didn't naturally exist. A design that has been used for centuries. The arch bridge represents a major leap forward in engineering. The arch is a curved structure that distributes weight outwards along its curve to its supports, called abutments. This clever design allows arch bridges to span much greater distances than beam bridges. The Romans were masters of arch construction, building countless bridges throughout their vast empire, many of which still stand today as testaments to their skill. The Romans used a material called pozzolanic concrete, a type of concrete made with volcanic ash. This concrete was incredibly strong and durable, and it allowed them to build massive structures, including bridges, that could withstand the test of time. The secret to their success lay in the careful mixing of ingredients and the precise placement of the concrete within wooden forms. This mixture still holds up today on various structures. Constructing the arch itself required a temporary wooden framework called centering. This framework supported the arch stones, or voussoirs, while the mortar dried and the arch became self-supporting. Once the arch was complete, the centering was carefully removed and the bridge was ready to bear weight. This delicate balance of forces and precise construction was essential for the arch to function correctly. Ancient bridges often faced the challenge of fluctuating water levels. During floods, the force of the water could damage or even destroy bridges. To mitigate this risk, engineers incorporated features like pointed piers, which helped to deflect the flow of water, and flood arches, which allowed floodwaters to pass through the bridge without damaging the main structure. Planning for the unpredictable was key to longevity. Another interesting type of bridge is the segmental arch bridge. Instead of a single, continuous arch, these bridges are made up of multiple smaller arches, or segments. This design allowed for lighter construction and could be adapted to uneven terrain. Segmental arch bridges were particularly common in China, where they were often built over canals and waterways. Chinese bridge builders also excelled at using materials like bamboo and timber to create innovative bridge designs. Suspension bridges, for example, were built using woven bamboo cables suspended between towers. These bridges were incredibly strong and could span impressive distances, showcasing the ingenuity of Chinese engineering. The natural world provided the materials for great construction. Cantilever bridges rely on projecting beams that are supported at only one end. Imagine two beams extending outwards from opposite sides of a river, meeting in the middle to create a span. Ancient cantilever bridges were often built using timber and stone, and they required careful balancing of weight and forces to remain stable. This design highlights a mastery of weight distribution. The Inca civilization of South America was renowned for its suspension bridges made of woven rope. These bridges were essential for traversing the steep valleys and canyons of the Andes Mountains. The rope bridges were incredibly strong and durable, capable of carrying heavy loads and withstanding the harsh mountain climate, a marvel of engineering and material science. The construction of ancient bridges was a labor-intensive process. Workers used simple tools like hammers, chisels, and levers to shape and position massive stones. They relied on teamwork and coordination to lift and move heavy materials, often using ramps and scaffolding to reach great heights. These bridges were true marvels of human collaboration. Many ancient bridges were not just functional structures, they were also adorned with decorative elements. Carvings, sculptures, and inscriptions were often added to celebrate the bridge's builders, commemorate important events, or simply enhance its aesthetic appeal. These decorations added a layer of artistry and symbolism to these essential structures. The Pont du Gard, a Roman aqueduct bridge in France, is a prime example of both engineering prowess and architectural beauty. This massive structure not only carried water across a valley, but also served as a testament to Roman engineering skill. Its elegant arches and precise construction continue to inspire awe today, a structure that blends utility with artistry. The Rialto Bridge in Venice, Italy, is another iconic example of ancient bridge design. This arched bridge, built in the 16th century, spans the Grand Canal and is a major landmark of the city. Its intricate design and bustling shops make it a popular destination for tourists and locals alike, a hub of commerce and transportation blended seamlessly. The ancient bridges we've discussed faced numerous challenges, including weathering, earthquakes, and the constant flow of water. Engineers had to account for these factors in their designs and employ techniques to protect the bridges from damage. Regular maintenance was also essential to ensure the bridge's long-term survival. A constant battle against the elements. Understanding the engineering behind ancient bridges provides valuable insights into the ingenuity and resourcefulness of past civilizations. By studying these structures, we can learn about the materials, techniques, and design principles that were used to create them. This knowledge can inform modern engineering practices and inspire new innovations. History provides a blueprint for the future. Many ancient bridges are still in use today, serving as vital transportation links and historical landmarks. These bridges stand as testaments to the durability and ingenuity of ancient engineering. Their continued use is a reminder of the lasting impact of these remarkable structures. They continue to serve their intended purpose after centuries of use. If you're enjoying this look into the engineering of ancient bridges, be sure to subscribe to the channel and click the bell notification. By subscribing, you'll be notified of new videos that uncover mysteries and marvels from the past. What other engineering marvel would you like to see featured? Preserving ancient bridges is crucial for protecting our cultural heritage. These structures represent important milestones in human history and provide valuable insights into the past. Conservation efforts are essential to ensure that these bridges continue to stand for generations to come. Protecting the past for the future is essential for understanding our place in the world. The study of ancient bridges highlights the importance of interdisciplinary collaboration. Engineers, historians, archaeologists, and architects all play a role in understanding and preserving these structures. By working together, we can gain a more complete picture of the engineering feats and cultural significance of ancient bridges. Multiple perspectives are needed for full comprehension. Exploring the engineering behind ancient bridges is a journey through time, revealing the ingenuity and resourcefulness of past civilizations. These bridges stand as testaments to human problem-solving, innovation, and the enduring power of engineering. They remind us that even with limited resources, humans can achieve remarkable feats. The power of the human spirit is on full display. From the simple beam bridge to the complex arch bridge, each type of structure reflects the specific needs and resources of the civilization that built it. By examining these designs, we can gain a deeper understanding of the cultures and societies that shaped our world. Each design has a unique story to tell. The legacy of ancient bridge builders lives on in modern engineering practices. Many of the principles and techniques used in ancient bridge construction are still relevant today. By studying these structures, we can learn valuable lessons about design, materials, and construction. The foundation for current construction was laid long ago. Imagine the challenges faced by ancient engineers: the lack of modern tools, the limited availability of materials, and the unpredictable forces of nature. Yet, despite these obstacles, they were able to create structures that have stood for centuries. Their achievements are a testament to their skill, dedication, and unwavering belief in their ability to overcome any challenge. The obstacles were large, but not insurmountable. As we conclude our journey across ancient bridges, let us remember the ingenuity and resourcefulness of the people who built them. These structures are not just pathways across rivers. They are symbols of human innovation, collaboration, and the enduring quest to connect with one another. They truly connect us with the past. Before you go, if you have any recommendations for content like this, feel free to let me know in the comments. Or if you have questions about ancient engineering, I will do my best to answer in the comments section. The story of ancient bridges is a story of human endeavor, a tale of overcoming obstacles and connecting communities. It is a story that continues to inspire us today, reminding us that even the most ambitious dreams can be realized with vision, skill, and a little bit of ingenuity. Engineering is about far more than mathematics and science, but problem-solving and ingenuity. Let's carry that spirit of innovation forward, inspired by the remarkable feats of engineering from our past. Embrace the challenges, seek solutions, and always strive to build bridges, both literally and figuratively, to connect people and ideas. Be inspired by the past and push into the future. Thank you for joining me on this exploration of ancient bridges. I hope you've enjoyed learning about the incredible engineering behind these remarkable structures. Until next time, be curious, think oddly,